Hi guys, Mr. Palmer back with our final installment of review for Work, Power, and Simple Machines. We just have one simple machine problem here where we have to calculate mechanical advantages and work and efficiency. This is number 9 on your review sheet. Hopefully you guys have tried this. I'm going to start with a little drawing for you guys. I think if we kind of draw this out, it'll be helpful. We have a ramp, right? That's an inclined plane. We're going to be pushing a box. We're given the mass up this ramp. It tells us it's 250 kilograms. And again, that's just the mass. It's not the weight. We'll have to go calculate that if we're looking for force. The ramp is 10 meters long. That means this part is 10 meters long and has a height of 3.3 meters. The height is this part over here. Right? That's how high we're going to be lifting it. So if we're looking at a ramp as an inclined plane, we are going to be applying some force. In this case, it tells us the force is 975 newtons. And we're applying that force up the length of the ramp to the top. And our goal is to lift the object. So we want to look at what is the work we put in, what is the work we get out. So let's start there. Work in and work out. So A asks us to find the work in, and our work in is always FE times DE, right? That is the effort part, is what you're putting in. Well, it says you're applying 975 newtons times a distance up the ramp of 10 meters. So that's going to be 9,750 joules. Again, work in joules. B, what's the work we're going to get out? Well, that's what the machine is doing, FR times DR. What you have to understand about this is that our ultimate goal is to lift the object to the top of the ramp. The force, our resistance, is the weight of the box. That's FG. And the distance it moves is the height of the ramp. That's the 3.3. So how are we going to get this? This FR is going to become FG, which is going to be mg to get the weight, times the distance, which is going to be our height. So let's substitute in. The mass is 250 times 9.8, which is g, times the height, which is 3.3. So that means we're going to come out with 8,085 joules. Oops, let me look at 5. Part C, it says, what's the work that's lost? Well, it's the difference between these two. If you're putting in 9,750 and you're only getting out 8,085, something's had to be lost. So let's go to part C. If we want the work that is lost, you're going to take the work that you put in, you're going to subtract what you're getting out, which is going to be less. So you put in 9,750 and you're only getting out 8,085. That leaves you with a difference of 1,665 joules, right? And that was lost to friction. D is asking us for the efficiency, and the efficiency is the ratio of work in to work out. So here's my equation right here. I can even just plop it down. That's our work in over the work out. Well, we've already calculated the work in and the work out. The work out was 8,085. The work in was 9,750 times 100. And that's going to give us 82.9%, which is pretty good for a ramp. Obviously, there's going to be friction involved. You're always going to get an efficiency that's under 100%. You can't get something from nothing, right? The work that you're going to be doing, right, is not, you're never going to get 100% efficiency. You certainly can't get more than that. Last two things, the IMA and the AMA. So looking at our two equations here for part E and for part F, IMA and AMA. So let's start with the actual mechanical advantage first. Again, that's the ratio of the forces. The IMA is the ratio of our distances. So let's plug our numbers in for these guys. If we look at the forces that we applied, right? The resistance force was the load. That was 250 times 9.8. That was the weight of the box. Dividing that by what we applied 975. If you do the math there, you should come out with 2.51, and that is a unitless number. It's a ratio. You don't have to put in any units there. If we look at the ideal mechanical advantages and our distances, well, how far did we move it? We moved it up the ramp 10 meters, and the ramp lifted it 3.3 meters. So we wind up with a mechanical advantage of 3.03. And you can actually use these two to calculate the efficiency as well. The efficiency can also take our actual mechanical advantage divided by your ideal mechanical advantage times 100, and you'll get the exact same efficiency of 82.9%. 2.51 over 3.03 times 100 will also give you 82.9%. It's just another way of doing it. And that's it. If you guys have any questions, come and find me. Send me a message on Classroom or on my YouTube channel, and I'll be sure to get back to you as soon as I can.